So far, I mentioned 4 different languages and used many words that you need to know and be aware of. To make things easier, let Expo do this job for you and reduce the number of things that you need to care about. To make the maintenance easier and let the community iterate faster, we decided to create a module system that reduces the costs and technical debt to a minimum. So hello everyone. So sometimes we come across the need to use some native APIs or like third-party libraries in our ReactNative applications. But sometimes there is no such library available yet, or like all of them are of poor quality or even worse, unmaintained, which is right now unfortunately pretty common. So today I'm going to talk a little bit about native modules, why creating and maintaining them might be hard and challenging, and how Expo can help you in this process. But first, let me introduce myself. I'm Tomasz. I work at Software Mention as a tech lead of the Expo SDK team. I usually work on the core parts of Expo, but also created and maintain a bunch of Expo SDK libraries. And yeah, you can find me on Twitter under the Sapeta handle. At Software Mention is a software agency based in Krakow in Poland with almost 200 developers already. And we've been using ReactNative for our clients' projects since the very beginning. We contribute to its development and are authors of the most popular open source libraries for ReactNative, such as ReactNative Gesture Handler, Reanimated, Screens, and also co-authors of React Navigation and Expo. At the beginning of this year, my company organized a State of ReactNative survey. So there was also a question that we asked the responders what were the backgrounds before they started using ReactNative. That was a multiple choice question, and like front-end here means something other than React. So it might be some confusion, like why React is like bigger than front-end, but yeah, it's the other ones. And it's clear that the largest group here consists of web developers who already have some experience with JavaScript. But what is important for this group of people who just started programming to write a native modules? Ideally, if you can write native modules in JavaScript, but we can't, since JavaScript is not the native language on mobile platforms as opposed to the browsers. But no doubt, the most important things are an easy way to bootstrap a module, having a good documentation, modern and accessible language with a large amount of online resources so we can learn a new language and platform faster. And the other group of mobile and desktop developers is much smaller. You would ask why. So some mobile developers say that ReactNative is not truly native, and so would rather keep doing native. To deny it and convince them to migrate to ReactNative, writing native modules and views should be as easy as it is right now in native mobile apps, at least for these developers. And right now, to migrate a native app to ReactNative, like it would be, I think, the best if you can just reuse the existing logic and only add a connecting piece so that this logic, native logic, can be like exported to JavaScript. But this logic can sometimes be really complex, and the native module system needs to be capable of reflecting like this complex logic on the native side, on the JavaScript side. Let's create a ReactNative library and see what we can do by, like we can do this by running this command. And this will set up a library and also an example app where we can try things out. And here is the structure of the folder created by this script. And we'll quickly go through some of those files. So the module created simply multiplies two numbers. Here is the implementation in Java for Android. And we specify like what the module name is and implement a multiply function with React method annotation. We also need a specification class. It's for the new architecture, basically. And this specification needs to extend the native turbo module compat spec, which is code generated. So it doesn't really mean too much. And for compatibility reasons, we also have got another specification, but this time with the method declaration as well. So it might be a little bit confusing that we have to support two architectures at the same time. We have like very similar classes for each of the architecture. I think it's not that easy to handle everything. And on iOS, we have also two files. The first one is a header. And to support both architectures, we also need to use the preprocessor directive to use different interface depending on the architecture. And in the implementation file, we need to export the module and its methods using macros. And for the new architecture, we need to include another method which mixes Objective-C and C++. So basically, this file is in Objective-C++. And on the JS side, we have even more code that should probably be extracted to the core. I would say it's kind of a boilerplate code here. And additionally, we need a specification in TypeScript that will be used by CodeGen to generate native specifications that I showed before for Android. And to sum up, there is a lot of code just for a simple module that multiplies two numbers. And another way to write a native module is to directly use JSI. JSI stands for JavaScript interface. It's generally not recommended to use, and it's more for advanced developers. But I wanted to show you how it could look like, as this is what libraries such as Reanimated, ReactNative Skia, or ReactNative Vision Camera use. So we have a C++ lambda that is called a host function. It receives a this value and all the arguments passed from JS. And now we create a JS function from this host function, and then we get the global object from the runtime to decorate it with our function. Well, it's definitely much more powerful as you have full control directly on the JS values, so you can modify them. But here we don't have any arguments types validations. And also calling it asynchronously would require us to write even more and more complex code. So far, I mentioned 4 different languages and used many words that you need to know and be aware of. To make things easier, let Expo do this job for you and reduce the number of things that you need to care about. Let's replace those languages with more modern ones, and let's stop thinking about the architectures and all those other scary words. So in Expo, our team needs to maintain a large set of libraries, and maintaining native modules over time and in constantly changing environment is quite expensive. I think we have like somewhere around 70 packages in our monorepo, so it's quite huge amount. And we found out that existing React Native API for native modules is not scaling very well for us, and it's giving us some additional overhead on many levels, from onboarding new contributors to writing a lot of boilerplate code. And to make the maintenance easier and let the community iterate faster, we decided to create a module system that reduces the costs and technical debt to a minimum. And one of the difficulties of writing React Native modules is context switching between the vastly different languages and paradigms for writing native modules for each platform. And due to the differences between those platforms, it cannot be completely avoided, but we feel the need to have just one common API and the documentation to simplify the development as much as possible to make it easier for a single developer to maintain a library on multiple platforms. And at Expo and Software Mention, we believe that the new architecture is the future of React Native. So all Expo modules work with the new architecture without adding any piece of C++ code. And like all existing Expo SDK packages already support the new architecture without even checking like which architecture is used by the app. And we want to not only build the powerful Expo SDK libraries, but also make them easy and more intuitive to use by app developers. A native module that is just a flat object with a set of some functions is not enough in our opinion. And for example, to bring some web or Node.js specifications to React Native, the module needs to support things like dynamic properties or native classes. Otherwise, we would have to write a lot of code on the JavaScript side just to try to make the API object-oriented from the flat, like a set of functions, which is very, very complicated. You need to trust me. And also, who wants to write boilerplate code? Let's get rid of it as much as possible. I mentioned about the cross-platform API in domain-specific language. So we already know JSX in React. It's a good example of the DSL syntax. And also, we have a SwiftUI on iOS, which is also another example that confirmed that, as Mandalorian said, this is the way to build a hierarchical data structure in a more maintainable and readable way. And in this case, it's a view hierarchy. And the same approach was then adopted by Jetpack Compose for Android, which also proves its cross-platformity. Let's review how we would write an Expo module with the same functionality. We can use the create Expo module command for that. So here we have the module in Kotlin, and like the module definition over there is basically the DSL syntax that I mentioned. And it's used as a source of truth for what the module exports to JavaScript. And so the module is exported under my Expo module name with a constant and one async function that multiplies those numbers. Now let's jump to Swift. Doesn't it look familiar? It's almost the same, and the differences are only on the language differences, like language-specific level. And on the JS side, we only need to use required native module with the name that we just used in our definition, and that's it. So let's go back to the native definition, and I will be referring only to Swift, since as you may saw already, like the syntax is very similar, but it would work like the same way in Kotlin, except those language-specific differences. And now, based on the module definition, the module object is then built on the JS side and installed in the global object under Expo Modules namespace. But here, the problem is that this multiply function is an async function. So why do we need to, well, switch to a different thread and do this command asynchronously, since it's a pretty fast and easy operation that doesn't have to be deferred to another thread? So sometimes you also want like this async function to run on the main thread, which is also called UI thread. Like for example, if you want to present a modal or like do some modifications in the view hierarchy or whatever. And to avoid crashes, it has to be called from the main thread. And you can use the run on queue modifier. It also looks pretty similar to what we do in SwiftUI and Jetpack Compose to modify the component. And this specific function has this weakness of being an async function. So let's remove the async prefix, and the function will immediately be exported as a synchronous function without returning the promise and switching the thread. Moreover, you can even go further and we can return another definition from the function. So here we have a function that can prefetch something from like the given URL, and you want to return a subscription that you can then abort from JavaScript. If you prefer properties over getters and setters, we've got that covered as well. So you can use a property component which basically maps to something that you can on JavaScript. You can use object and define property where you can define dynamically what the property needs to return. You can also use a custom setter and so on. Okay, but validating and converting arguments from JavaScript to native is also painful, especially when it comes to dictionaries where each entry of the dictionary needs to be validated and converted separately. So we implemented a special structure that we call a record that can automatically do this for you. So if you have written a native module before, you've probably written code something like this. And this is not very good. As for example, like if we look at the quality variable, we are not even sure if it's actually a number, because in Objective-C, like all those entries in the dictionary are just a pointers to something. And because of the nature of Objective-C, the dynamic nature basically lets us assign a pointer to any type without even throwing any errors. So if you want to validate those parameters, it would take some more code. So instead of using the untyped dictionary values, you can write your own struct that will not only make it convenient to use, but also perform validations automatically. Here is our record that provides some default values as well. And we can refine this type even further, because we know that the media types here, but the media types are like the options that we can use is like images, videos, or all types of medias. So we can use another enum with all those cases. And the enum only need to implement the enumerate protocol. And now we switched the string to the media type enum, which defaults to images option. And now if someone passes something else than those cases, then it will throw an error automatically. So to summarize, now in the functions body, we are sure that the options are properly typed and validated. It works perfectly with auto-completion in Xcode and Android Studio, and there is no chance that the typo will get unnoticed. For optional fields, the default values are already provided. The function fails early in case of unexpected, and it's easy to keep in sync with the equivalent type in TypeScript. But native module is not only the native thing. The other use case to dive into native code is to write a native React component. So to export native view, we only need two things. This is the implementation of the platform-specific view and the definition. So the Expo view class basically inherits from UI view on iOS, and on Android it's a group view. And to react to prop changes, we can add a prop component to its definition, specifying its type, how the change should affect the view. And here we also have an example that you can also use some other types as argument types. So in this case, it's a UI color. So whenever your user of your library passes like some RGBA, hex, string, or CSS named colors, it will be automatically converted to the platform-specific type, such as UI color. However, the React component is not just props. Sometimes we need to call a function on the ref, on the component. So with Expo Modules, you can do that, but just adding a native function inside of the definition. So let's imagine that we have a camera view, and we want to take a picture from like the current frame. So of course, we need a way to tell the view to take this picture, but doing this through props doesn't sound like a good idea. So we do such things using React refs. Since we interact with the UI, all view functions must be asynchronous as they run on the main thread by default. And typed arrays are kind of like array-like objects that provide a mechanism for reading and writing binary data in memory buffers. So in JavaScript, you have a few different types of typed arrays depending on the element type. And typed arrays are very useful for manipulating on big raw binary data. And using typed arrays is much more efficient as they are optimized by JavaScript engines. What's also important is that typed arrays are basically pointers to a buffer in a memory, and the memory is then shared between JavaScript and native, so we can read and write directly to the same memory used by both environments. And the most common use cases for typed arrays are like some things that sometimes require some heavy work. So it's, for example, audio, video processing, cryptography, or some network traffic optimizations. In Bridge and Turbo modules, there is no easy way to use them, as there is no built-in API to interact with them directly. And as an example of the usage of typed arrays as a function, it's a function get random values, which is defined by web crypto specification. With typed arrays built in the module API, implementing that function on iOS is just a few lines of code. However, it doesn't handle the case where the status means where this native function returns an error status. So let's check the status and return an exception in this case. So here is the exception that we throw from here. And since we recommend separating the exception messages to separate classes, so your code doesn't look like bloated with all those error messages. So we make a separate class for the exception and separate the exception message from the code. And to nicely handle errors, we adopted the idea from Java that is known as chainable exceptions. So in my opinion, it's pretty useful for debugging. So you can immediately see what went wrong and from where the error comes from. You can see all the exceptions that were thrown along the way down. So the root cause is always in the root message, in the error message. Another thing that was not possible so far is mutating the JS objects in your native functions that you can pass to the native function. And note that this must run on the JS thread since we operate and modify JavaScript value directly. And if we expect that this function can only handle JavaScript objects and not just primitive values, we can replace the argument type to JavaScript object and the appropriate exception will be automatically thrown if someone passes something else than a JavaScript object. All right, time for something harder. And so as I said, to be able to fully implement some web and Node.js specifications and make library APIs more intuitive and object-oriented, the native module needs to be capable of having a way to define native classes. And so here is an example of the file stream that could be defined. And we have some code that runs as part of the JS constructor and a write function that accepts strings that are streamed to the file at a given path. And here, you basically associate this JS class with another native class, and the base class of this native class is called the shared object. It basically allows us to associate a single JS object with a single native object, so you can use them interchangeably and share some data between JS and the native. And so each time we initialize this JS object, the native implementation of the constructor returns an instance of the native object. So like those objects are associated with each other. And whenever you pass this JS object to another native function, you will get an instance of its associated native class. And for those of you who used Reanimated, you're probably familiar with the concept of shared values. Generally speaking, shared values from Reanimated work in the similar way, but they point to a primitive value, not an object. It's much more powerful than what Reanimated implemented. And another feature of Expo Modules are AppDelegate subscribers. So on iOS, we usually have a singleton object called AppDelegate. And the setup instructions for some libraries often include instructions to copy some code into your AppDelegate if they need to respond to some platform events such as inbound links, notifications, or foreground and foregrounding, backgrounding the app. And to simplify and automate the setup, we've made a mechanism called AppDelegate subscribers that allows your library to subscribe to calls to the singleton AppDelegate functions. So in order for this to work, the app's AppDelegate must only inherit from Expo AppDelegate, which forwards their calls to all the subscribers. A good example of the library that uses Expo AppDelegate subscribers is a ReactNative Google sign-in that needs to listen for the event that is triggered when the URL is open from the app. And this approach doesn't need any Expo config plugin, which would require us to use some regexes to modify the code in the AppDelegate, which could break the behavior if, for example, multiple libraries want to hook into the same method. Like everything that we built at Expo, all our products, such as React Native, Expo CLI and Expo SDK, Expo modules also work and can be used with any React Native app. Let's talk about the future of Expo modules. So since our DSL looks like SwiftUI and Jetpack Compose, it feels obvious to just build them in. And SwiftUI has some nice features that are not available in UIKit, which is the implementation for view hierarchies on iOS. So SwiftUI would definitely enable some new possibilities for our native views. And so far, there are a few Expo modules that some people from the community built, but they all were embedding a single SwiftUI view. So this view doesn't support children props, so it cannot nest other SwiftUI views into your native SwiftUI view. So this is kind of a problem so far, and we want to solve this by even letting you to build a nested hierarchy of SwiftUI and Jetpack Compose views. And here's where the new architecture comes in, because it basically allows us to build this thing. It was not possible in the architecture so far. So I'm really looking forward for the new architecture to build this. I'm also happy to announce that we are working on adding support for more platforms, since right now you can only use iOS, Android, and of course web. There are some subtle differences between iOS, macOS, and tvOS, especially in terms of the views. And since the Modules API is mostly an abstraction, these platform differences can mostly be resolved in the core part of Expo Modules, so you don't have to care about this. And as a bonus, I believe some of the existing Expo SDK packages will just start working on these platforms out of the box. Okay, another feature of the shared objects that I already mentioned is something that we want to use to share the references between different libraries. So let's imagine that we want to use an image picker and then render the resulted image. So right now, the image picker libraries usually save the image to the file system, return the path to this file, and then you pass this URL or path to the image component, which needs to read this file again and then render it. Why not just pass a reference to the native, like on iOS, it would be UI image. So we don't have to write and read from file system. So with shared objects, it will be possible without even having a dependency between those two image libraries. And it's not just about image picker. Like in Expo SDK, we have also a media library, just kind of a camera roll, also image manipulator, which like each manipulation that you use from Expo image manipulator is again saving this file to file system, which is unnecessary, especially if you want to run a few transformations, manipulations on the image. And since the core part of Expo modules is now stable, we finally have some bandwidth to work on some new libraries. We've already built Expo Image as a replacement for React Native Fast Image, which unfortunately became unmaintained. We also have a pretty good native tests coverage for the Expo Modules API. I think all of those like mechanisms that you use for native unit tests and also UI tests, it would be, I think, now a nice thing to also make it public for other library developers to make writing native unit tests easier. The documentation for the Modules API is already out there. It doesn't contain everything that I mentioned today, since some of the features will be released as stable in Expo SDK 49 later this month. You can also join us on our Expo Developers server on Discord, where you can find some help when you want to build some Expo modules and also give us some feedback. And there is also a dedicated Creating Expo Modules channel where we are all eager to help. So thanks for listening. Does anybody have any questions?